Nebulae are among the most beautiful and mysterious structures in the universe. Vast clouds of gas and dust drifting through the darkness of space. At first glance, they look like cosmic paintings, glowing in surreal colors, shaped into pillars, bubbles, and endless swirling forms. But nebulae are far more than scenery. They are the hidden architecture of creation, the places where stars are born, where planets begin their long journey, and where the universe constantly reshapes itself. The word nebula simply means cloud, yet these clouds span light years, containing enough material to form thousands of suns. In the cold emptiness between stars, nebulae float as a raw substance of the cosmos, made mostly of hydrogen, the simplest and most abundant element in existence, mixed with traces of helium and heavier elements forged in ancient stars. Within these clouds, gravity works patiently over immense spans of time. A nebula may appear still, but inside it, slow motion change is always unfolding. Over millions of years, tiny variations in density become seeds of collapse. A region slightly denser than its surroundings begins to pull more matter inward. Slowly, the cloud contracts, growing hotter and more compact, until a protostar forms at its center. This is the beginning of stellar life. In this way, nebulae are often called stellar nurseries because they give birth to new generations of stars. One of the most famous examples is the Orion Nebula, a glowing region visible even to the naked eye, where countless young stars are forming right now. Inside such nurseries, radiation and stellar winds from newborn stars carve the surrounding gas into dramatic shapes, creating pillars and cavities that astronomers can observe across vast distances. These structures are not permanent. They are temporary sculptures, shaped by light, gravity, and motion, slowly changing as stars ignite and blow their birth clouds apart. Yet, nebulae are not only places of birth, they are also places of death. When massive stars reach the end of their lives, they explode as supernovae, scattering heavy elements into space. The remnants of these explosions expand outward, forming nebulae filled with enriched material, the elements that will one day become planets, oceans, and living organisms. The Crab Nebula, for example, is the expanding aftermath of a supernova observed nearly 1,000 years ago. In this sense, nebulae are both beginnings and endings, the recycling system of the universe. They transform the ashes of dead stars into the seeds of new ones. This cosmic recycling is one of the reasons the universe becomes more complex over time. Early in cosmic history, the universe contained mostly hydrogen and helium, but through generations of stars living and dying, heavier elements accumulated. Nebulae became richer, more chemically diverse, capable of forming rocky planets, and eventually the building blocks of life. Nebulae also reveal the deep connection between light and matter. Many nebulae glow because they are energized by nearby stars. Ultraviolet radiation strips electrons from atoms, and when those electrons recombine, the gas emits light in characteristic colors. Hydrogen often produces a reddish glow, while oxygen can shine in blue-green tones. These colors are not artistic choices. They are fingerprints of physics, telling astronomers what elements are present and what processes are unfolding. Other nebulae do not emit light at all, but instead appear as dark silhouettes, dense clouds blocking the starlight behind them. These dark nebulae may be the earliest stage of star formation, cold and hidden, waiting for gravity to ignite their cores. In some regions, dust grains inside nebulae begin to clump together, forming the earliest seeds of planets. Around young stars, disks of gas and dust swirl, and within these disks, particles collide and grow. Over time, they can become worlds. In this way, nebulae are not only star factories, but planet factories as well. Every solar system begins inside a cloud of interstellar material, shaped by the conditions of its nebula. Nebulae help scientists understand the structure of galaxies. The Milky Way is threaded with clouds of gas and dust, and nebulae mark regions where star formation is active. Spiral arms glow with nebulae because those arms are rich in material, constantly forming new stars. Over cosmic time, galaxies evolve through cycles of nebulae forming stars, stars living and dying, and material returning to space. This endless cycle is how the universe renews itself. Modern telescopes have transformed our understanding of these structures. The James Webb Space Telescope can peer through dust that blocks visible light, revealing newborn stars hidden deep within nebulae. Infrared observations show the warm glow of protostars still wrapped in their birth clouds, allowing scientists to witness the earliest moments of stellar evolution. Each new image is not only breathtaking, but also a map of creation in progress. Nebulae remind us that the universe is not static. Space is not empty. It is alive with processes unfolding over immense spans of time. Stars are constantly being born, and stars are constantly dying, and nebulae are the stage upon which this cosmic transformation occurs. Without nebulae, there would be no new stars, no planets, and no future generations of galaxies. They are the great reservoirs of possibility, floating silently in the darkness, waiting for gravity and time to sculpt them into something new. And nebulae also shape the future of their surroundings. As stars ignite, they release powerful radiation and winds that can compress nearby gas, triggering new waves of star formation, or they can disperse the cloud, ending the birth process. In this way, nebulae are dynamic ecosystems, balancing creation and destruction. When we look at a nebula, we are looking at both the past and the future of the universe, the remains of ancient stars and the birthplace of stars yet to come. In their glowing clouds, we see the universe in the act of creation, endlessly rebuilding itself from the simplest elements into the vast complexity of the cosmos, reminding us that even in the quiet darkness between the stars, the universe is always becoming something new.